Welcome students, in this class we will be learning differentiation by substitution followed by parametric differentiation. This is the third lecture of the series on methods of differentiation. So foremost what we will do is we will learn a few formulae. So first one is differentiation of sine inverse of x is going to be 1 over square root of 1 negative x squared. So this is a very important formula. Now subsequently you got a formula for cos inverse of x. Now cos inverse of x is nothing but you got a positive sign, just place a negative sign and followed by root of 1 negative x squared. So formula number 3, this is differentiation of tan inverse of x. Now this is going to be 1 over 1 positive x squared, and the formula 4, differentiation of cot inverse of x. Now you got a positive sign here, just place a negative sign and divide it by 1 positive x squared. Now formula number 5 is differentiation of secant inverse of x. Now this is equal to 1 over x times square root of x squared negative 1, and for formula 6, differentiation of cosecant inverse of x. Now you got a positive sign, just place a negative sign and divide it by root of course you need to have a x followed by root of x squared negative 1. So all you need to do is to get a grip of 1, 3, 5, and concurrently you will be able to obtain the 2, 4 and 6. So having got this, let us see some of the proofs of these formulae. Now we will start off by proving d over dx of sine inverse of x is equal to 1 over square root of 1 negative x squared. So this is our first question. So foremost what we are going to do is we are going to be considering the left hand side. What is that? Differentiation of sine inverse of x. Now what I'm going to do is I'm going to let theta be equal to sine inverse of x. So if I were to take theta to be as sine inverse of x, I can clearly rewrite this as d over dx of theta, which is nothing but d theta over dx. Now I have already taken theta to be a sine inverse of x, so this would mean sine theta is equal to x. So I'm going to rewrite it as x is equal to sine theta. Now differentiating this with respect to theta, we get dx over d theta is equal to differentiation of sine theta is going to be cos theta. Now we need d theta over dx, so therefore d theta over dx is equal to 1 over cos theta. So this d theta over dx can be rewritten as 1 over cos theta. But what is cos theta? Cos theta is nothing but square root of 1 negative sine square theta. But what is sine theta? Sine theta is nothing but x. So sine squared is going to be 1. That's going to be x squared here, right? Because sine theta is equal to x, so sine squared is equal to x squared, so hence we would get 1 over root of 1 negative x squared. Now what is on the left hand side? The left hand side is d over dx of sine inverse of x. So hence this is a good place for us to draw the red line. So hence we have proved differentiating sine inverse of x would give us 1 over square root of 1 negative x squared. Now I'm going to do the same proof by another method. Now we can also obtain the same result using another technique. Now we already studied this. G dash of f of x is equal to 1 over f dash of x. So the derivative of the inverse function is defined in this fashion. So from here, if f of x is the given function, then g of x is the inverse of f of x. So based on this, we have got this particular definition from the previous lecture, and we have used this to do many questions. Now we will take f of x to be as sine x, and since g of x is its inverse, then this would mean my g of x would be equal to sine inverse of x. So the left side, therefore d over dx of sine inverse of x is nothing but d over dx of g of x, which is nothing but g dash of x. So we have already got this g dash on the left hand side. Now the question is, since we know that g dash of f of x is equal to 1 over f dash of x. Now the question comes here is, what should we do to have a x here? Because we need to get g dash of x, right? So to have a x here, we would take the substitution that x is g of x. Since g of x is the inverse of f of x, then this would mean that f of g of x would give us x. So if I were to take this as 2 and take this as 1, hence 2 would be rewritten as g dash of f of g of x, which is equal to g dash of x, because g of x is the inverse of f of x, so f of g of x will be equal to x. So that's exactly what happens here. So hence I am placing here x. So g dash of x is going to be equal to 1 over f dash of x. So we are going to be working with this. Now since f of x, clearly you can see that f of x is equal to sine x. I'm using this space here. Since f of x is equal to sine x, f dash of x is equal to cos x. So that would mean g dash of x, therefore g dash of x is going to be 1 over cos x, but x is g of x, so that's going to be cos of g of x, but my g of x is sine inverse of x, so this is going to be 1 over cos of sine inverse of x. So that's exactly what we've got here, but we will have to find the sine inverse of x. Now if sine inverse of x is equal to theta, then this would mean x is equal to sine theta. So if I were to take a box like this and place this as theta, now sine theta, this opposite side, hypotenuse side and adjacent side, so this is actually x over 1. So if this is x, this is going to be 1, and this is going to be root of 1 negative x squared. So from the value of sine theta, I have actually got the entire Pythagorean triangle completed. Clearly what we can do is we can replace sine inverse of x with cos inverse of x. That's always possible. So if I were to write the value for cos theta, this is going to be adjacent side over hypotenuse. My adjacent side is found to be a square root of 1 negative x squared. Hypotenuse is 1. So let me use this space. So therefore cos theta is square root of 1 negative x squared. So from here I can write theta to be as cos inverse of root of 1 negative x squared. So this is a very important point. So what I'm going to do, I'm going to replace sine inverse as cos inverse of square root of 1 negative x squared, right? So clearly we can see that the cos and cos inverse, they get cancelled, giving me 1 over square root of 1 negative x squared. So what do we have on the left hand side? On the left hand side we have g dash of x. What is g dash of x? G dash of x is nothing but d over dx of sine inverse of x. So that is what I'm going to place, d over dx of sine inverse of x. So hence this is a good place for us to draw the red line. So we have seen two different methods, students, and you're free to use either of them. So we will go on to the next question. Students, we are given this question, y being equal to tan inverse of x negative cot inverse of x divided by tan inverse of x positive cot inverse of x. We are expected to find dy over dx at x is equal to negative 1. So foremost, let me start off by consider y being equal to tan inverse of x negative cot inverse of x divided by tan inverse of x positive cot inverse of x. Now we know that tan inverse of x positive cot inverse of x is equal to pi over 2. I will be using this over here. So this is going to be tan inverse of x negative cot inverse of x divided by pi over 2. I can rewrite this as 2 over pi times tan inverse of x negative cot inverse of x. Now this is equal to y. Now differentiating with respect to x, we get, so what do we get? This is dy over dx is equal to 2 over pi is a constant, I'm taking it out. So I will have to differentiate tan inverse of x, that's going to be 1 over 1 positive x squared, and I will have to differentiate cot inverse of x, that's negative 1 over 1 positive x squared. Now this is equal to 2 over pi. I'm going to take 1 positive x squared as LCM. I will get 1 positive 1, which is equal to 2 over pi of 2 over 1 positive x squared. Now this is my dy over dx. Now we are expected to find dy over dx at x is equal to negative 1. So that would mean this is 2 over pi times 2 over 1 positive negative 1 squared, which is equal to 2 over pi times 2 over 1 added with 1, this is going to be 2, 2 can be cancelled, giving me 2 over pi. So therefore dy over dx at x is equal to negative 1 is 2 over pi, and that's a good place for us to box the result. So this is the solution for this question. Students, we will move on to the next question. Students, we are given this question, if y is equal to tan inverse of square root of 1 positive x negative square root of 1 negative x over square root of 1 positive x followed by square root of 1 positive x, this is actually 1 negative x, right, because we can't have 2 root of 1 positive x. Of course we can add, but the problem is wouldn't be of much challenge. So this is the question given, we are expected to find dy over dx. Now whenever you are given questions of this fashion, do not directly apply or try to differentiate. What you need to do is you have to first try to simplify it. So for simplifying, you need to use the technique of substitution. So for this, I'm going to start by taking x to be equal to cos 2 theta. So if I were to take this as 1, therefore I can rewrite 1 to be as y is equal to tan inverse of square root of 1, in place of x I'm going to substitute cos 2 theta followed by a negative sign and 1 negative cos 2 theta divided by square root of 1 positive cos 2 theta positive root of 1 negative cos 2 theta. So you got something like this. Now there is a formula. We know that. What do we know? We know that 1 positive cos 2 theta divided by 2 is equal to cos squared theta. So this is divided by 2. So this would mean 1 positive cos 2 theta can be rewritten as 2 times cos squared theta. Now similarly you got 1 negative cos 2 theta to be equal to 2 times sine squared theta. So what I'm going to do, I will be substituting these in this given expression. So if I were to take this as 2, I'm going to state here, therefore using the substitution 2 can be rewritten as y is equal to tan inverse of square root of 1 positive cos 2 theta, this is going to be 2 times cos squared theta negative root of 2 times sine squared theta over root of 2 times cos squared theta positive root of 2 times sine squared theta. This is equal to tan inverse of root of 2 times, I'm taking the square root of cos squared theta. Now usually you need to have a modulus sign there, but the domain is not specified here. So that would mean we have the liberty to simply place cos theta there. So this is going to be negative root of 2 times sine theta divided by root of 2 times cos theta positive root of 2 times sine theta. So this is what we have got. Now I'm going to take root 2 out, so tan inverse of root of 2 is taken out, so this is going to be cos theta negative sine theta divided by root of 2 cos theta plus sine theta. So root 2 can be cancelled, giving me tan inverse of cos theta negative sine theta divided by cos theta positive sine theta. So what I'm going to do is I'm going to take cos theta out. So this is tan inverse of, if we were to take cos theta out, this is going to be 1 negative sine theta over cos theta divided by, take cos theta out, 1 positive sine theta over cos theta. Now clearly cos theta can be cancelled, so 1 negative sine theta over tan theta, sine theta over cos theta, so that's tan theta. So this is equal to, so you need to place the huge parenthesis there, so this is tan inverse of 1 negative tan theta divided by 1 positive tan theta. Now this is a beautiful formula. Now what is this formula? I wish to draw your attention to this formula. Tan of A negative B is equal to tan A negative tan B divided by 1 positive tan A tan B. Now if I were to take A to be as pi over 4 and B to be as theta, this is going to be tan pi over 4, that's 1. This is tan theta, this is 1 positive, tan pi over 4 is 1, and that's going to be tan theta. So this is for your understanding. Now I can directly rewrite this with this. So this is equal to tan inverse of tan of pi over 4 negative theta. Now clearly the tan inverse and this tan, they get cancelled, giving me y is equal to pi over 4 negative theta. We are expected to find dy over dx. So differentiating with respect to x, what do you get? Dy over dx, this is 0, differential of theta. So we can't just obtain theta directly, so we need to do something over there. So we need to know what exactly theta is. Now let me just show you the substitution. I've taken x to be equal to cos 2 theta. So I'm going to use this space available here. So x is cos 2 theta. Move this x to the left, so you get cos inverse of x is equal to 2 theta. So from here I can write theta to be as 1 over 2 times cos inverse of x. So I need to take this value and substitute it here. So probably what I can do, I can have a reduction and write the new transformation. Y is pi over 4 negative 1 over 2 times cos inverse of x. So we are expected to differentiate this value. Now differentiation of pi over 4 is 0, but I got a negative sign and a 1 over 2, and I need to differentiate cos inverse of x. So what is the differentiation of cos inverse of x? That's negative 1 over root of 1 negative x squared. Negative negative is positive, so I can rewrite this as 1 over 2 times root of 1 negative x squared. So this is our final answer, and so we can box this. So students, the takeaway points is, though the question given is complicated at the given standard, yet we were able to achieve the solution by substitution. So substitution is a very important technique that you will have to gain mastery over. So we will move on to the next question, students. Students, we are given this question: y is equal to tan inverse of square root of 1 positive x squared negative 1 over x. We expected to find dy over dx at x is equal to 1. Now, as mentioned to you earlier, we would have to simplify this given question first before we could take on the differentiation part. And whenever you see 1 positive x squared, the standard substitution for this would be put x to be equal to tan theta. So if I were to take x to be as tan theta, let me just take this as 1. Therefore I can rewrite 1 to be as y is equal to tan inverse of square root of 1 positive tan square theta negative 1 divided by tan theta. Now we know that secant square theta negative tan square theta is equal to 1. So from here secant square theta is equal to 1 positive tan square theta. So this is for your understanding. Because of this, if I were to take this as 2, therefore I can rewrite 2 to be as y is equal to tan inverse of square root of, in place of 1 positive tan square theta, I'm going to place secant square theta followed by negative 1 and tan theta. Square root of secant square theta will be secant theta followed by negative 1 and tan theta. I'm going to rewrite secant theta as, now we know that secant theta is 1 over cos theta and tan theta is sine theta over cos theta. So these two are trigonometric identities which you already know. So based on that, this is equal to tan inverse of, in place of secant theta it's 1 over cos theta followed by negative 1, and in place of tan theta is sine theta over cos theta. So this can be further rewritten as tan inverse of 1 negative cos theta divided by cos theta. I can flip this off, so this is going to give me cos theta over sine theta. Cos theta can be cancelled, giving me tan inverse of 1 negative cos theta over sine theta. Now it is imperative that we know this formula. Now 1 negative cos theta is 2 times sine squared theta over 2. Now how did I get this? It is imperative for you to know that 1 over cos 2 theta over 2 is equal to sine squared theta. So this is the standard formula. Now if I were to take 2 theta to be a sum t, so let me just take it like this. So let 2 theta be equal to sum t. So from here theta is equal to t over 2. So therefore what happens, this can be rewritten as 1 negative cos t divided by 2 is equal to sine squared. Theta is t over 2, so this is t over 2. Now I need only one negative cos t, so this is going to be 1 negative cos t is equal to 2 times sine squared t over 2. So why did I do this? I did all this just to show you that 1 negative cos t or cos theta can be rewritten as 2 times sine squared theta over 2. Now similarly, sine theta can also be rewritten as 2 times sine theta over 2 times cos theta over 2. So I would be using these two formulae over here, so that this is going to be tan inverse of 2 times sine squared theta over 2 divided by 2 times sine theta over 2 times cos theta over 2. So clearly sine theta over 2 and sine theta over 2 can be cancelled. 2 and 2 can be cancelled. This would leave me with tan inverse of sine theta over 2 over cos theta over 2. Sine over cos, that is going to give me tan theta over 2. Now tan inverse and tan, they can be cancelled, giving me theta over 2. So what is on the left hand side? On the left hand side we started with y. So all these things are for your understanding. So you got a y there, a y here, a y. So y is equal to theta over 2. Now we need to know what is theta. So let's go back. We have taken x is equal to tan theta. So since I'm using this space here, since x is equal to tan theta, I can push tan on the side. So tan inverse of x is equal to theta. So I'm going to use this. So this is equal to tan inverse of x. I got a 1 over 2. I will place it here. Now differentiating with respect to x, we get, so what do we get? Dy over dx is equal to 1 over 2. Differentiation of tan inverse of x is 1 over 1 positive x squared. But we are expected to find dy over dx at x is equal to 1. So at x is equal to 1, dy over dx, I'll just place x is equal to 1 over here. So this is equal to 1 over 2 times 1 over 1 positive 1, which is 1 over 2 times 1 over 2, which is equal to 1 over 4. So this is a good place for us to draw the red box, red line. So that's the solution, students. I hope you understood this question. We will move on to the next one. Students, we are given a beautiful question. If f of x is equal to sine inverse of 2 raised to the power of x positive 1 divided by 1 positive 4 raised to the power of x, then we are expected to find f dash of 0. Now I'm going to start off by writing, consider the given, which is f of x is equal to sine inverse of, now 2 raised to the power of x positive 1, I'm going to write it as 2 raised to the power of x times 2 divided by 4 raised to the power of x. I'm going to rewrite it as 2 raised to the power of x raised to the power of 2. Now this can only be solved using a substitution that is able to neutralize sine inverse. So that's the catch here. So what I'm going to do is I'm going to start by taking, let 2 raised to the power of x be equal to tan theta. Now I'm going to do the working on this side to show you. Now if I were to do that substitution, 2 raised to the power of x is equal to tan theta, this is going to be tan theta, I got a 2, I can place the 2 there, divided by 1 positive tan theta raised to the power of 2. Now this is equal to sine inverse of 2 times tan theta divided by 1 positive tan square theta. Now the question is, what exactly is 2 tan theta over 1 positive tan square theta? So let me just show that to you here. So we have got 2 tan theta, probably I'll use the same color, 2 tan theta divided by 1 positive tan square theta. I'm going to rewrite this as tan theta, let me write tan theta as sine theta divided by cos theta, and tan square theta is sine square theta over cos square theta. So this is equal to 2 times sine theta over cos theta divided by, if you were to take the LCM as cos squared, this is going to be cos square theta plus sine square theta divided by cos square theta. So I can flip this. If I were to flip it, this is going to be 2 times sine theta over cos theta times cos square theta over, now this would lead me to 1, okay? So a cos and a cos can be cancelled. So this is going to give me 2 times sine theta cos theta. Now 2 times sine theta cos theta is nothing but sine 2 theta. So what have I done here? I have changed 2 times tan theta over 1 positive tan square theta into sine 2 theta. So all I need to do is take this and substitute it in place of 2 times tan theta over 1 positive tan square theta. So this is going to be sine 2 times theta or sine 2 theta. Now clearly I can cancel a sine inverse with the sine there, giving me 2 theta. That's fair enough. On the left hand side I've got the function f of x, so that's y. In fact you can either write it as y or f of x, that's okay. So now the most important point is I need to know the value of theta. Let me use the space here. So 2 raised to the power of x is equal to tan theta. So from here, if I were to extract theta, this is going to give me tan inverse of 2 raised to the power of x is equal to theta. So I have got, let me just place the f of x for y. So f of x is equal to 2 times, in place of theta, this is going to be tan inverse of 2 raised to the power of x. So this is what I've got. Now we need to obtain f dash of x. So I'm differentiating f. So this is going to be 2 is a constant. So differential of tan inverse of x is going to be 1 over 1 positive. In place of x, I've got 2 raised to the power of x. That has to be raised to the power of 2. So that's fine. Now I need to differentiate 2 raised to the power of x. So let me use the space here. Now if you have y is equal to a raised to the power of x, if you want to find dy over dx, this is going to be a raised to the power of x times ln a. It's the standard differentiation for a raised to the power of x. So that would mean 2 raised to the power of x differentiation is going to give me 2 raised to the power of x times ln 2. Fair enough, we are almost there. Now we are expected to find f dash when x is equal to 0. So let me go back here. So therefore f dash when x is equal to 0 is going to be 2 times of 1 over 1 positive 2 raised to the power of 0, right? So that's going to be 1 squared is 1 times 2 raised to the power of 0 times ln 2. So what is this? This is equal to 2 times of 1 over 1 positive 1, that's going to be 2 times 2 raised to the power of 0 is 1 times ln 2. 2 and 2 can be cancelled. That's going to give me 1. 1 multiplied with 1, that has to be multiplied with ln 2, which in turn would give me ln 2. So what is this? This is nothing but f dash of 0. So this is a good place for us to draw the red line, and that is the solution for this beautiful question. Students, we are starting parametric differentiation. We've been given this question, x being equal to a of theta negative sine theta and y being equal to a of 1 negative cos theta. We are expected to find dy over dx. Now clearly you can see that x is a function of theta and y is a function of theta, and we are expected to find dy over dx. Now when they are asking you to find dy over dx given the functions in this fashion, then the general formula would be, I would actually have to start with dy over d theta and then divide it with dx over d theta. So this is the formula that you will have to follow if you are given a parametric function, and from here you would be able to extract dy over dx. So foremost, what I will do is I will start off like this. Consider y being equal to a of 1 negative cos theta, and I need to find dy over d theta. So therefore, differentiating with respect to theta, we get, so this would be dy over d theta is equal to, a is a constant, differentiation of 1 is 0, differentiation of cos is negative sign, so that's going to be positive sine theta. So I'm going to rewrite it like this. Also consider x to be equal to a of theta negative sine theta. I would be differentiating this with respect to theta. We get, this is dx over d theta is equal to a of, differential of theta is 1, differential of sine is cos. So we have achieved our dy over d theta and dx over d theta. So if we were to take this formula as 2, therefore 2 can be rewritten as dy over dx is equal to dy over d theta divided by dx over d theta is now, dy over d theta is a times sine theta, dx over d theta is a times 1 negative cos theta. I can clearly cancel the a's, and then I've got the sine theta. Now I can use the formula. I can rewrite sine theta as 2 times sine theta over 2 times cos theta over 2, and I've got 1 negative cos theta. That's going to be 2 times sine square theta over 2. So clearly 2 can be cancelled, sine theta over 2 and sine theta over 2 can be cancelled. This is going to give me cos theta over 2 over sine theta over 2, cos over sine, that's nothing but cot. I got an angle of theta over 2, so place that. So what is this? This is nothing but dy over dx, and it is a good place for us to draw the red line. So this is the solution for this beautiful question. So we will move on to the next question, students. Students, we are given another parametric question. X is equal to a times secant cube theta and y is equal to a times tan cube theta. We are expected to find dy over dx at theta being equal to pi over 3. So first, let us write down the formula. We know that dy over dx is given to be as dy over d theta over dx over d theta. So let me put that in a box. So having got that formula, let me consider y being equal to a times tan cube theta. I will first start off by differentiating this with respect to theta, and we would get dy over d theta to be equal to a times, this is going to be 3 times tan squared theta. Differentiation of tan theta is going to be secant squared theta. Now let me consider x being equal to a times secant cube theta, and then I would be differentiating this with respect to theta. We would get dx over d theta is equal to, a is a constant, so differentiation of secant cube theta is going to be 3 times secant squared theta times differentiation of secant theta, that's going to be secant theta tan theta. I can rewrite this as 3 times a times secant squared into secant, that's going to be secant cube theta times tan theta. So if I were to take this as 2, therefore 2 can be rewritten as dy over dx is equal to dy over d theta, that's going to be 3 times a times tan squared theta secant squared theta over 3 times a times secant cube theta tan theta. Now 3 a can be cancelled, a tan theta and a tan theta can be cancelled. Now this is secant square theta, and I got a secant cube theta, so the secant square theta and secant square theta can be cancelled, giving me 1 over secant theta. So this is what is left. Of course I have a tan theta that has to be placed there, so I've got tan theta over secant theta. My tan theta can be rewritten as sine theta over cos theta. My secant theta is 1 over cos theta. So if I were to simplify it, this is going to be sine theta over cos theta times cos theta. So sine theta, cos theta can be cancelled, leaving me with sine theta. So I get dy over dx to be equal to sine theta. But the requirement is find the value of dy over dx at theta being equal to pi over 3. So at theta is equal to pi over 3. So we need to get that value. So what is this? This is equal to sine of pi over 3. Sine pi over 3 is sine 60. Sine 60 is root 3 over 2. Right? So this is a good place for us to draw the red line for this question, students. So that is the end of this. Students, we are given this question: x is equal to 8 times of cos t positive t times sine t, and y being equal to 8 times of sine t negative t times of cos t. We are expected to find dy over dx. Now I would be using this formula. We know that dy over dx, in this case the parametric value is in terms of t, and so the formula is going to be dy over dx is equal to dy divided by dt over dx divided by dt. So this is what we would be using. So what I would do is I will try to use this space that I've got here for calculating the value for y. In fact, I want to find dy over dt. So y is given to be as 8 times of sine t negative t times cos t. So differentiating with reference to or with respect to t, this is going to be dy over dt is equal to a is a constant. Differentiation of sine t is cos t followed by negative sign. Now we will have to apply UV method here. So it's going to be t times differentiation of sine cos t is going to be sine t, but there is going to be a negative sign here. So I'm placing the negative sign there, followed by positive, and that has to be followed with the differentiation of t. So I would now have cos t here. So if I were to rewrite this, this is going to be a of cos t negative negative positive t times sine t. This is going to give me negative cos t. Now clearly positive cos t negative cos t can be cancelled, giving me a times of t times sine t. Now what is this? This is my dy over dt. I will just box this for the time being. So I've got dy over dt. So now I need to obtain the value for dx over dt. So I'm going to use this this part here. So my x is given to be as a times of cos t positive t times of sine t. So dx over dt, so we are differentiating with reference to t, so it's going to be a of differential of cos t is negative sine t positive. This is going to be UV product rule being applied here. So this is going to be t times of cos t positive sine t. So I can rewrite this as a of negative sine t positive t times cos t positive sine t. So clearly positive sine t, negative sine t can be cancelled, giving me a times of t times cos t, which is nothing but dx over dt. So I've got dy over dt, I've got dx over dt. Now I need to replace them. So this is equal to dy over dt is a times t sine t, dx over dt is a times t cos t. My a over here can be cancelled with the one there, t can be cancelled, so I get sine t over cos t, which is tan t. So this is a good place for us to draw the red line, students. So we'll move on to the next question. Students, we are going to start this new topic. In this topic you are going to learn the concept of differentiating a function with respect to another function. Of course it might be looking a little bit different, but it is a simple concept. Now if you are asked to find dy over dx, what exactly is happening? You are differentiating y with respect to x, right? Similarly, if I were to take y to be as some function, then we can also rewrite this as differentiation of this function with reference to x. Now what if I have to take x to be as, say, some function, say g of x? In that case we are actually performing the differentiation of this function with reference to another function. So this is exactly what is happening. Now the question is, how are we going to get this out, or how are we going to get the solution? It's simple. All you need to do is divide the numerator and the denominator by dx. So this is going to be d of fx divided by dx divided by d of gx divided by dx. So this is exactly what we have to do. So this in turn would mean all we are doing is to find the differentiation of the first function and then divide it by the differentiation of the second function. Simple as that. That's all. So have this in mind, and this is a good place for us to draw the red line. So how are we going to achieve this? Simple. Let us take it one example and see how the concept works. So let me just take this illustration. So I'm going to state this: differentiate ln of sine x with respect to square root of cos x. So what exactly is happening here? We are actually expected to differentiate ln of sine x with respect to root of cos x. Now what is this? This is nothing but d over dx of ln of sine x divided by d over dx of root of cos x. So what is ln of sine x differentiation? It's going to be 1 over sine x times differentiation of sine x, that's going to be cos x, divided by, what is this? Root of cos x is nothing but cos x raised to the power of 1 over 2. If you were to differentiate this, this is going to be 1 over 2 times cos x raised to the power of 1 over 2 negative 1 times differentiation of cos x, that's going to be negative sine x. So if you were to rewrite this, this is going to be cos x over sine x divided by Now I got a 1 over 2, so I can actually flip and move this 1 over 2. But anyway, let me just first simplify this. So what is this? This is cos x raised to the power of 1 over 2 minus 1. That's going to be 1 over, cos x is going to go down because of the index being negative, because when 1 over 2 is subtracted from 1, of course the sign dictates the outcome. So this is going to give us cos x raised to the power of 1 over 2. Of course there is a 2 there, and then I have a negative sin x. Now I can rewrite this as cos x over sin x. Now if I were to, now let me just use one more step. So this is going to be 1 over 2 times root of cos x times negative sin x. So if I were to flip this, this is going to be cos x over sin x times 2 times root of cos x divided by sin x. Of course there is a negative sign there. So this is what we have got, and I can rewrite this as 2 times cos x times root of cos x divided by sin x times sin x gives me sin squared x. Of course there is a negative sign here. So we can simplify this further. It depends on your requirement, but I think this is a good place for us to stop. Since we have this question, we are expected to differentiate tan inverse of square root of 1 positive x squared negative 1 over x with respect to tan inverse of x. Now we cannot outrightly perform the differentiation of this function and divide it by the differentiation of this function. So what we need to do is, first we need to simplify this. So that's exactly what I'm going to do. So I'm going to start off by saying consider tan inverse of square root of 1 positive x squared negative 1 divided by x. Now what I'm going to do, I'm going to say let x be equal to tan theta. Now when you're taking a substitution, you will have to use the same substitution for the other function also. So this is going to be equal to tan inverse of square root of 1 positive tan squared theta negative 1 divided by tan theta. So this is equal to tan inverse of square root of 1 positive tan square theta. 1 positive tan square theta is root of secant square theta followed by a negative 1 divided by tan theta. Now this is equal to, I can simply take the root here for the fact that domain isn't been given here. So root of secant square theta is going to be secant theta negative 1 divided by tan theta, and then I'm going to take secant theta as 1 over cos theta followed by a negative 1, tan theta as sin theta over cos theta. I can rewrite this as tan inverse of 1 negative cos theta over cos theta. I can flip this. This is going to be cos theta over sin theta. So clearly cos theta can be cancelled, giving me tan inverse of 1 negative cos theta divided by sin theta. So this is what I've got. Now I can actually simplify 1 negative cos theta, and that is going to be 2 times sin square theta over 2. I can also rewrite sin theta as 2 times sin theta over 2 times cos theta over 2. So clearly the 2 can be cancelled, a sin and a sin theta can be cancelled, leaving me with tan inverse of tan theta over 2, because sin theta over 2 divided by cos theta over 2 is going to be tan theta over 2. Now clearly tan inverse and tan can be cancelled. That would leave me with theta over 2. All this for the first function. Now for the second function, when we take x is equal to tan theta, tan inverse of x is equal to tan inverse of tan theta, which means tan inverse tan gets cancelled, giving me theta. So I've got a theta over 2 and I've got a theta. So the solution is, so if I were to take the first function as say sum f of x divided by the second function as sum g of x, and differentiating the first function with respect to the second function is actually nothing but differentiating theta over 2 divided by theta. So this is going to give me, differentiating theta over 2 gives me 1 over 2, and differentiating this gives me 1. So the outcome is going to be 1 over 2. So this is a good place for us to stop. So this is the final solution, students, and it's a good question. Students, we have given a beautiful question. Knowing such questions could land you up in top level graduate programs with all the good things provided. So this is a top level question. So we are expected to find the value of P and Q. We have been given the quantities as d of sine inverse of 2x times root of 1 negative x squared divided by d of sine inverse of x. That is assigned to be as P, and similarly we got d of tan inverse of root of 1 positive x squared negative 1 over x divided by d of tan inverse of x. That's given to be as Q. We are expected to find the value of P and Q, and then use the value of P and Q in evaluating 2 times fractional part of P with Q. So this is not an ordinary parenthesis, this is the fractional part. So you will have to extract the fractional part and then add it to the product of P times Q. So that is the reason I just mentioned that this is a top level question. Now foremost, what I'm going to do is I'm going to start off like this. Consider Q to be equal to d of tan inverse of square root of 1 positive x squared negative 1 divided by x, and you have to differentiate this with reference to this function d of tan inverse of x. Now in the previous question I have exactly shown you how to obtain that. Now I would like to request you all to go back and watch that illustration, how exactly I have obtained the value for Q. So I'm just going to borrow that value. So from the previous question I have got the value for this differentiation to be as 1 over 2. So now that I've got the value of Q, I need to go and get the value for P. So let us do that. I'm going to start off by stating, consider my P to be equal to d of sine inverse of 2 times x times root of 1 negative x squared divided by, this is the differentiation, we have to perform the differentiation with reference to d of sine inverse of x. So we got two functions. Now before we could attempt to differentiate them, I would like to simplify them. So what I'm going to do is I'm going to say, let us first simplify the numerator. So what's in the numerator? It is sine inverse of 2x times root of 1 negative x squared. So what I'm going to do is I'm going to take, let x be equal to sine theta. So if I were to take x being equal to sine theta, this is going to be equal to sine inverse of 2 times of sine theta. So probably I will just place them in parentheses, times root of 1 negative sine squared theta. So this is equal to, because I can always replace 2 sine theta cos theta by sine 2 theta. So this is equal to sine inverse of 2 times sine theta cos theta is sine 2 theta. So clearly I got a sine inverse and a sine, they can be cancelled, giving me 2 theta. So this is for the numerator. So let me use this part of the page. So let us consider the denominator. So what do we have in denominator? Sine inverse of x. I need to use the same substitution. X is equal to sine theta. So this is equal to sine inverse of sine theta. Clearly sine inverse and sine can be cancelled, and this is giving me theta. So now we will have to obtain the differentiation of this. So what is this? Hence, I'm going to state it here. Hence, P is equal to d of sine inverse of 2x times root of 1 negative x squared divided by d of sine inverse of x is equal to d of, this is simplified to 2 theta, this is simplified to theta. Now differentiation of 2 theta over theta, this is going to give me 2 times of 1, which is nothing but 2. So now, since that we have got the value of p, of course this is going to be 1, so I have not specified it, it's clearly understood. So we have our value for q, which is 1 over 2, and the value for p, which is 2. So hence, let us obtain the final solution. 2 times of fractional part of p positive q, positive p times q is equal to 2 times of, the value of p is 2, the value of q is 1 over 2, positive 2 times of 1 over 2. Now this is the fractional part, so we will have to get the fractional part of 2 positive 1 over 2. So whenever we have an integer, we can drop it. So that would mean we now have 2 times of 1 over 2, positive 2 times of 1 over 2. The 2 and 2 and can be cancelled, giving us 1 positive 1, which is equal to 2. So the final solution is 2, and that is a good place for us to draw the red line to this beautiful question. Students were expected to differentiate this function with respect to this function. So foremost, let us perform some simplification. So I will start off by stating, consider cos inverse of 2x squared negative 1. Now I would like to take the substitution as x is equal to cos theta. So you will have to use the same substitution for this function also. So if you were to do this, this is going to be cos inverse of 2 times of cos square theta negative 1. Now what is 2 times cos square theta negative 1? We got that formula, right? So that is going to be cos inverse of cos 2 theta. Now clearly cos inverse and cos can be cancelled, giving me 2 theta. Now coming to the other side, so let me just draw a parenthesis and start with this function. Consider root of 1 negative x squared. So substituting cos theta, this is going to be 1 negative cos squared theta, this is going to be root of sine squared theta, this is going to be sine theta. So I've got a 2 theta and a sine theta. So we need to differentiate. So if this is f of x and this is g of x, we are expected to find d of f of x divided by d of g of x. So this is equal to differentiating this divided by differentiating this sine theta. Differential of this is going to give me 2. Differential of sine theta is going to give me cos theta. But cos theta is x, so this is going to be 2 over x. But we are expected to find the value of the derivative of the differentiation at x is equal to 1 over 2. So at x is equal to 1 over 2, what happens? This is 2 over 1 over 2, which is equal to 4. So this is a good place for us to draw the red line. So this is a beautiful question, students. Students, we are given a beautiful question. A curve is parametrically represented as x being equal to sine of t positive 7 pi over 12, positive sine of t negative pi over 12, positive sine of t positive 3 pi over 12, and for y we got cos of t positive 7 pi over 12, positive cos of t negative pi over 12, positive cos of t positive 3 pi over 12. We expected to find d of x over y negative y over x, and we are to get that when t is equal to pi over 8. So foremost, what we are going to do is we need to perform some simplification. So I would start off by consider x being equal to sine of t positive 7 pi over 12 positive sine of t negative pi over 12 positive sine of t positive 3 pi over 12. So this is what I'm going to consider. Now what I would do is I would like to club these two together. Now this is of the form sine A plus sine B. Now what is the formula? That formula is 2 times sine of A positive B divided by 2 times cos of A negative B divided by 2. So this is the formula I would be using. So my A is t positive 7 pi over 12 and my B is t negative pi over 12. So A positive B, let me find that out, which is t positive 7 pi over 12 positive t negative pi over 12. This is going to give me 2t positive 12 is the LCM, so it's going to be 7 pi negative pi, that's going to be 6 pi, and 2t positive 6 pi over 12, which is 2t positive 6 divides 12 2 times, so pi over 2. So this is what I have got for my A positive B. Now A positive B divided by 2, so this is A positive B, so A positive B over 2 is going to be 2 times of t positive pi over 4 divided by 2, so the 2 can be cancelled, so this is going to be pi over 4. So this is for A positive B, and now we will have to find out what is A negative B. So A negative B is going to be t positive 7 pi over 12 negative, my B value is t negative pi over 12, so that's going to be, clearly t and t would be cancelled, giving me 7 pi over 12 positive pi over 12, which is going to be 8 pi over 12. So 8 pi over 12, 4 can divide here, 2 times 4 can divide here 3 times, so this is 2 pi over 3. So this is my A negative B, so therefore A negative B divided by 2 is going to be 2 pi over 3 divided by 2, which is going to be pi over 3. So I've got a value for A negative B over 2 and a value for A positive B over 2, so that's fine. So all I need to do is to substitute them in this formula. So therefore my x is going to be equal to 2 times, as I mentioned to you, I'm going to club these two things together, so it is going to be 2 times sine of t positive pi over 4 times cos of pi over 3. That's fine. So that has to be added with sine of t positive 3 pi over 12, so 3 can divide 12 4 times, so it's going to be sine of t positive pi over 4, so that's fine. Now since cos pi over 3, what is cos pi over 3? Cos pi over 3 is cos 60, which is equal to 1 over 2. So clearly this and this can be cancelled, giving me sine of t positive pi over 3 positive sine of t positive pi over is actually pi over 4. So pi over 4. So if I were to add this is going to be 2 times sine of t positive pi over 4. So we have got that for x. Now we need to simplify for y. So let's do that. Now let us consider y, which is given to be as cos of t positive 7 pi over 12 positive cos of t negative pi over 12 positive cos of t positive 3 pi over 12. Now I'm going to take this as a and I'm going to take this as b. So we will use cos a plus cos b formula. What is that? That's going to be 2 times cos of a positive b divided by 2 times cos of a negative b divided by 2. So now we will have to extract the values for a added with b divided by 2. So from here my a is t positive 7 pi over 12 and my b is t negative pi over 12. So this is what I've got. So now we will have to add a positive b. So if I were to add a positive b and I were to divide by 2, I would get the same result, right? Because the angles, see, this is exactly what we have got in the question. You see that? T positive 7 pi over 12, t positive 7 pi over 12, and in this case t negative pi over 12 and t negative pi over 12. So we would not have any changes at all. So a positive b over 2 is going to give me t positive pi over 4 and a negative b over 2 would give me pi over 3. So if I were to take this as say 2, hence 2 can be rewritten as, so y is equal to 2 times of, the only change is that we have a cos. So cos of t positive pi over 4 times, this is going to be cos of pi over 3 added with cos of t positive. Now 3 pi over 12, that's going to be pi over 4. So as I mentioned to you, cos 6t, that's going to be 1 over 2. So these two can be cancelled. This is going to give me 2 times cos of t positive pi over 4. So I've got a x, I've got a y. So let me just consider. So now we find x over y. So that's going to be, my x is 2 times sine of t positive pi over 4 and my y is 2 times cos of t positive pi over 4. 2 can be cancelled. This is going to be tan of t positive pi over 4. Now this is similar to tan of a plus b, which is equal to tan a plus tan b divided by 1 negative tan a tan b, right? So this, therefore tan of t positive pi over 4 will be tan t plus 1 divided by 1 negative tan t, right? Tan t times tan pi over 4, that's going to be 1. So this is what we have got. I can rewrite this as 1 positive tan t divided by 1 negative tan t. All this has come from x over y. So we need to simplify this further. Let's do that. So from here, let me use this part of the page. This is x over y. So therefore y over x is 1 negative tan t divided by 1 positive tan t. X over y is 1 positive tan t divided by 1 negative tan t. Y over x would be the exact opposite. Now we will have to find, now consider x over y negative y over x. So what is that? X over y is 1 positive tan t divided by 1 negative tan t. Negative y is 1 negative tan t divided by 1 positive tan t. If I were to take the LCM, 1 positive tan t with negative tan t, that's going to be 1 negative tan square t. So this is going to give me 1 positive tan t whole squared negative. This is going to give me 1 negative tan t whole squared. So I have to expand this. 1 positive tan square t positive 2 times tan t, and negative 1, this is going to be negative 2 times tan t, so that's going to be positive 2 times tan t, and positive tan square t with a negative sign, so negative tan square t divided by denominator. So clearly negative tan square t, positive tan square t can be cancelled. Negative 1, positive 1 can be cancelled. These two can be added. 2 tan t with 2 tan t will give me 4 tan t. So let me move on to the next page. So this is equal to 4 times tan t divided by 1 negative tan square t. So I need to find a way to simplify. I'm going to rewrite this as 2 times tan t divided by 1 negative tan square t. So this is going to be 2 times of tan 2t. So from here onwards, I would want you all to complete the question for t at pi over 8.